then what I'm asking for is that Aij is the same thing as Bij, no matter what the I and the j are. Yeah. So if I represent my matrices in this sort of abstract way that I showed you, where these are just the entries, I'm just asking that all the entries are the same. All of these guys are equal as numbers. Okay. So to be equal as matrices, you have to have the same dimension, and all your entries have to be equal. Okay. So let's just see an example of something that is equal and something that's not equal. Although writing an example of something that is equal is kind of, I don't know, it seems silly here. Let's see some examples. So this is going to be kind of dumb here, but these are the same, right? This entry equals this entry, this entry equals this entry, this entry equals this one, and this one equals this one. And of course, these two matrices are the same size. They both have 2 rows and 2 columns. So these are the same. Okay. Let's see an example of things that are not the same. That'll work. These two are not the same. And the reason being, they have different dimensions. This one has 2 rows and 3 columns. This one has 2 rows and 2 columns. Right, this is a 2 by 3. This is a 2 by 2. And so they cannot be equal just because they have different dimensions right off the bat. So the problem, of course, is that, you know, this 3, for example, I have nothing to pair it with over here because there's no third column. So there's nothing corresponding to this 3 over here. So I can't even really compare these matrices. It doesn't make any sense. So we're just going to say they're not equal, not the same. A better example of something that's not equal to would be something like this. Just change one of these numbers up here. These matrices have the same dimension. They're both 2 by 2. But I have one pair of entries that's not the same. This 4 and this 5 are different, but these are corresponding entries. They're both second row, second column, but they're not equal. So these are not the same matrix. They have 2 entries that don't match. Okay. So maybe this is a good time for me to pause just to ask if there are any questions. I've said a lot. Okay. If there are no questions, I'll just move on. So this is an equality or inequality of matrices. It's basically what we would want it to be, right? If they're going to be equal, they better just be literally the same matrix. Okay. But this will be, you know, thinking of it strictly in this way will be helpful for us when we go to solve equations. In fact, maybe on your activity that we'll start today, let's see an example of this. Okay. So let's do something a little more interesting than equality. Let's do addition. Let's find out how to take 2 matrices and add them together to get a new one. This pretty much works the way that we'd want it to also. Here's how it works. I'm going to write it in the abstract way, and then we'll just see examples that will hopefully make it clear what I mean. But I'll tell you that all we're going to do is I'm going to take one matrix and another matrix, and I'm just going to add the corresponding entries. So that's all we're going to do. We're going to just add the numbers together in the way we would want to. Well, let's make this really explicit. If A has the Aij entries and B has the Bij entries, then so long as A and B have the same dimension, if A and B have the same dimension, then I'm allowed to add them together, and this happens. A plus B will just be the entry where, will be the matrix whose entries are the sums of the entries of A and B. So I just add the corresponding Aij and Bij together. Okay. So note, I've had to point out that they have to have the same dimension. That's really important. The 2 matrices have to have the same dimension. And if they do, I just add them together by adding corresponding entries. So let me just tell you this. If A and B have different dimensions, then this doesn't make any sense. and we'll just say A plus B is undefined. We just won't even try to add them. So if we have two matrices with different dimensions, you just can't add them. We just throw up our hands and say it's undefined. Okay. This is our first big difference between matrix algebra and normal algebra. If I give you two numbers, I can always add them together. Yeah. You're never stopped from adding two numbers together. But we already see that there are going to be examples of two matrices that I can't add together. If I take any two matrices with different dimensions, I'm out of luck. I can't add them together. It's undefined. So we have examples where sometimes addition just isn't even defined for matrices. And that's just sort of the way it is. But we can still do a lot with it. So we will press on. So let me show you, some more explicit examples instead of just writing this abstract definition on the board. Let's do some examples here. Let's say A is this matrix, 1, 2, 3, 4. B is this matrix, -1, 0, 3, -2. I don't know. And let's say C is another matrix, like this. Okay. What is A plus B then? Well, according to our definition, first thing I need to ask is, do A and B have the same dimension? And they do. They're both 2 by 2 matrices, A and B. So I can add them together. And according to the definition, all I need to do is just take the corresponding entries and add them. So to get the first row, first column, I just take first row, first column of A and add it to the first row, first column of B. So I take 1 plus -1, and that's 0. To get first row, second column, I take 2 plus 0, that's 2. To get the second row, first column, I take 3 plus 3, that's 6. And then to get the last entry here, I'd take 4 plus -2, which is 2. So here's A plus B. That's my new matrix. And then just to check, what would like A plus C be? Well, first I need to ask, do A and C have the same dimension? Oh, they don't. A is a 2 by 2, C is a 2 by 3. Those are different dimensions. A plus C is undefined. Okay. Because, if I wanted to add something, I have nothing to add this 3 to, right? I've already paired these guys up if I tried to add these together. What do I do with these? I have nothing to do with those, so I just call this undefined because I can't pair up all the entries. Okay, so it's very important when you add to check that the dimensions make sense. They have to have the same dimension. Okay. So this is addition of matrices. I'll point out that in the same way that we do addition, we could do subtraction. There's really no difference other than we subtract instead of add. So we also know how to subtract matrices by, again, we just subtract the corresponding entries. So maybe if A is this matrix again, and B is, I forgot what the other one was, we'll just do this. If I have these two matrices here, A and B, they have the same dimension, so I could subtract them, and it would work like this. A minus B is just subtract the corresponding entries, do A minus B. So my first entry is 1 minus 1, which is 0. My next entry is 2 minus 0, which is 2. Then I come down and I have 3 minus -2. That's 3 plus 2, which is 5. And then 4 minus 4 is 0. So I get this matrix. So I can subtract matrices in the same kind of way that I added them. Just note that the order mattered here. I did A minus B, so I should take these and minus these, right? The correct order. Okay. So that's addition and subtraction of matrices. It works the way that, if I told you to make up a definition for me of addition of matrices, this is probably what you would come up with. That's how I would want it to work. Just add up the numbers correspondingly. We'll see tomorrow when we talk about matrix multiplication that same idea for multiplication just won't work. You can't just multiply corresponding entries. It's a little trickier, but I don't want to talk about that today. We'll talk about that tomorrow. Just be warned. This is comparatively easier than multiplying matrices. It'll be a little more complicated.